This is Steve Wright for YUVsoft with a tutorial on the Background Reconstruction tool. In the last tutorial, Advanced Stereo Generation, we saw how to use clean plates to create high-quality stereo conversion. In this tutorial, we'll see how to create those clean background plates using the Background Reconstruction tool, which is part of YUVsoft's 2D to 3D suite. We'll be using this clip that has major disparity between the foreground catapult and the background castle wall. We'll start by noting the streaking in the background here on the left edge of the catapult when the foreground object is shifted too much. The Background Reconstruction node will create a clean background plate to create a perfect stereo composite like this. To see how easy the Background Reconstruction node is to use, I'll start with a clean node. You'll find the Background Reconstruction node in the YUVsoft toolset here. The only required inputs are the original 2D clip and its depth map. You can also connect rotos to the mask input here to isolate specific objects, and we'll be taking a closer look at that in a minute. You can see from the property panel here that there are relatively few parameters to adjust. Once the inputs are connected, simply select the frame range you want to render clean plates for and hit the Start button. The clean plates are rendered to disk to be retrieved by the Background Reconstruction node when you need them. Here you can see the reconstructed background plate for this frame. The Background Reconstruction node looks at the depth map on a frame-by-frame basis to determine occluded or hidden background areas, then borrows pieces from nearby frames to fill in the missing pieces. It also supports complex motion, not just one simple moving plane in the background. The Background Reconstruction node is easy to use and eliminates much labor, which saves production time, labor, and cost. A second key advantage is that unlike other clean plate tools, it also creates a modified depth map for each clean plate, so you don't have to create one with compositing tools, another big time saver. Now let's take a look at a fully adjusted Background Reconstruction node to see how easy it is to dial in. The Background Reconstruction node actually has 4 outputs. First, of course, is the reconstructed background in the RGB channels. In the depth channel, you'll find the reconstructed depth map for the reconstructed background. In the YUVsoft initial mask channel is the initial occlusion mask that marks the background areas that are occluded or hidden and need to be reconstructed. Finally, in the mask channel, there's a remnant mask indicating areas it did not reconstruct because there was not enough motion or the node was uncertain what to do. The original default Background Reconstruction node did a good job without any adjustments at all, but with just a few refinements to the node's parameters, we can do even better. We only need to adjust the 3 parameters here in the occlusion estimation section to get the final results. The first parameter here is parallax, which has the same meaning as in the Stereo Gen node, where a value of 100 is equal to 1% of the frame width. The key difference is that the Background Reconstruction parallax should be a bit larger than the Stereo Gen parallax by around 10%. This ensures that the background region is reconstructed well behind the foreground edges. The No Occlusion Below Depth parameter tells the Background Reconstruction node to ignore occlusions that are further than this value from the screen, and turning off the Consider Horizontal Borders toggle causes it to ignore horizontal edges. We can see the effect that each parameter has by watching the YUVsoft initial mask channel. Adjusting the parallax from 200 to 300 widens the occluded areas to be reconstructed. Setting the No Occlusion Below Depth parameter to 86 ignores the far background further than 86 units from the screen. And disabling the Consider Horizontal Borders toggle will ignore horizontal edges. One very important point about working with the Background Reconstruction tool is that the depth map must be as accurate as possible. The depth map for the Stereo Gen node might be dilated or softened for best stereo, but for the Background Reconstruction node, it needs to be very tight. In the previous tutorial, Advanced Stereo Generation, the use of clean plates was demonstrated using 2 Stereo Gen nodes, one for the foreground and one for the background clean plate. There were 2 very important rules. First, the StereoGen occlusion output must be on for the foreground and off for the background. And second, the StereoGen node parameters must be identical, typically by linking the parameters between the nodes. These same two rules apply to the StereoGen nodes used with the background reconstruction node. The output of StereoGen 1 has stretched background pixels that we want to fix with the background reconstruction node. Opening its property panel, we can see that since this is the foreground layer, the occlusion output is on. Checking the alpha channel, we can see the occlusion mask, which is then softened with the blur node for the final stereo composite with the merge node. The black areas are where the clean background plate will come through. Note that this is the A input of the merge node, making it the foreground layer of the composite. The output of the background reconstruction node here forms the clean plate to be used as the background layer of the composite. Again, the occlusion output of the background StereoGen node is off, and the clean plate is connected to the B input of the merge node, making it the background layer of the composite. The merge node operation is set to matte so that the clean background will be composited under the foreground using the black regions of the occlusion mask from StereoGen 1. The result is a very high-quality stereo conversion, even with large movements of the foreground object. The background reconstruction node represents a major breakthrough in rapid clean plate construction, resulting in very fast stereo conversions without using any rotomasks. However, if the scene content requires rotomasks to isolate problem objects, the background reconstruction node can use those as well. We'll look at that next. When there are many overlapping moving objects in a shot, there can be multiple areas of the background which potentially suit the same area. As a result, an automated approach cannot resolve the situation, so a separate rotomask and background reconstruction node is needed for each object. Here we'll take a look at the basic workflow for using a rotomask with the background reconstruction node, then later tutorials will go into greater detail on the use of rotomasks for more complicated cases. Here's the problem. Using the rotomask and depth map intended for stereo generation causes the background reconstruction node to produce unsatisfactory results. By correctly pre-processing both the rotomask and the depth map, we can get excellent results like this, where the background has been completely reconstructed. For stereo generation, the depth map will be typically a bit wider than the object edges and even softened a bit, so an erode operation is usually needed to shrink it to fit the edges precisely. The rotomask, however, typically fits the object edges very accurately, so we need to perform a dilate operation to expand it a bit beyond the depth map edges. For proper operation of the background reconstruction node, the depth map needs to fit the object edges precisely, and the rotomask needs to be at least 1 pixel wider than the depth map. Note that when the mask input is connected, the occlusion estimation parameters are ghosted out. Because the node is getting all of its reconstruction information from the rotomask and depth map images, these parameters are not used. Now here's an important tip. The rotomask should include all blurry edges of objects, such as motion blur or depth of field blur, in order to avoid introducing an object halo into the restored background. Returning to the catapult clip, here are the kinds of artifacts you might see if a rotomask is narrower than its object edges. You can also get similar results if the depth map is too narrow. If you cannot get an exact fit for the depth map, it's better that it be a bit too wide than too narrow. So what problems are created if the rotomask is narrower than the depth map instead of wider? Here's the catapult source clip we saw earlier. Here's the result if the rotomask is too narrow. Artifacts everywhere. You can easily tell if you have this problem by inspecting the depth map that the background reconstruction node outputs. It becomes corrupted, as does the rotomask. This version of the background reconstruction node cannot reconstruct the background if there's no motion of objects relative to the background. However, this case will be addressed in the background propagation tool, which is currently under development. The Background Reconstruction tool represents a real breakthrough in stereo conversion productivity. In some cases, it can completely reconstruct the background automatically, but when shots are more complicated, it's easy to add rotomasks to pinpoint the background restoration exactly where it is needed.